Hello, my name is Nikki, and I currently work at the Data X Lab at Berkeley, and I'm covering the NLP module for this class. So today we'll be diving into feature engineering and text representation, and so you guys will learn how to extract information from text and represent it numerically. So the subtopics I will be covering today is OneHot encoding, bag of words model using count vectorizer, Engram encoding, and TF-IDF vectorizer. So first, let's take a dive into what exactly is feature engineering and what is text representation. So feature engineering has a very broad definition, and it's a process of transforming the raw data to improve the accuracy of models by creating new features from existing data. And for NLP, what we're specifically doing, the new features that we're creating is numerical data. So we're taking the raw data, which is textual data, and transforming it into features that are numerical. And this kind of leads us into the definition of text representation, which is numerically representing text to make it mathematically computable. So when you're putting this data into machine learning models, for example. And as you can see, these two definitions for NLP are very intertwined. So let's move on to the first topic that we're covering, which is OneHot encoding. And so how OneHot encoding turns data into numerical data is it creates a distinct possible value for each feature. So for example, you can take a categorical data such as the name column, and what it does is it creates a new feature vector such as name underscore Brian, name underscore Francine for each of the distinct possible values such as Brian and Francine. And so what you're left with is this numerical data where the magnitude of each dimension is meaningful. And so how you would make a OneHot encoding, there's two ways. One, scikit-learn pandas. And for scikit, you would import it and then you would call it and you would fit and transform the column values that you want to do. So keep in mind, OneHot encoding only works for categorical data. So for example, when you run it on the age column, which already has numerical data, it doesn't do anything to it, which is why we're only passing in the column names name and kind, and then you would transform the data. And you can also do one-hot encoding in pandas, and all you would do is just call get underscore dummies, and you would pass in the column names you want. And if you want to run the entire data frame through one-hot encoding, you would just pass in the data frame variable name. So moving on to the second topic, the bag of words model. What a bag of words model is it extracts features from text. So things to keep in mind is that stop words are not included. Word order is lost since it's extracting just the individual words from the sentence or the text that you're passing in. And it uses sparse encoding, which means that not every single word is included, especially more words that are jargon specific to perhaps an industry. Because what it does is, let's say you have this sentence, learning about machine learning is fun. What it does is it puts a vector number for each time that word is used. For example, fun is used once, learning is used twice, learning and learning, and machine is used once. Therefore, it creates this vector where it has one at fun, two at learning, and one at machine. As you can see, it doesn't use stop words such as about and is. And if there was a super technical word in here, it might not show up. And as you can see, word order is lost because it's just done in alphabetical order. So how you would implement bag of words model is, for example, you have a sample text or a document. So this could be sample text or documents passed in here, and you would import count vectorizer, and you would get rid of the stop words. And since it would be in English for us, you would put English here, and then you would fit the sample text. And if you're curious about what words were kept, because as I said, this is does sparse encoding, and also if you're curious about what stop words were removed, you can enumerate through it and you would get the feature names because each feature is a word that is being used, that is in the sentence. So the next topic that we're talking about is Engram encoding. And this is useful when you're trying to capture local word order. So for example, if you're trying to keep words in term like two words together, you would use an n equals 2. And so this means is it looks at the two words that are next to each other after stop words have been removed. So book well, well written, and written not, and not enjoy. So this is what is called counts over sliding window. So it keeps sliding over to the next word. And this is just an example of n equals 2, which is actually called bigram encoding. But if you wanted to do words in sliding windows of 3, you could pass in n equals to 3. So that would be book well written not enjoy, and etc. And so how you would implement this is you would call count vectorizer again, but you would pass in Engram underscore range. And when you pass in 1 and 2, what it does is it actually takes words that are 1. So this is basically a bag of words model, right? And also takes words that are in pairs of 2. So for example, it would take book as well as book well. And then you would fit it. And this is called a bigram once again, since we are looking at n equals to 2. And if you want to see what words were kept, once again, because it does remove stop words and it is sparse encoding. So moving into the final topic, TF-IDF vectorizer. This one converts a collection of raw documents to a matrix of TF-IDF features. So what TF-IDF features are is it really stands for term frequency inverse document frequency. And it represents text data by indicating the importance of the word relative to other words in text. So how it's calculated is there's 2 parts to it, the TF part and the IDF part. So its term frequency part is the number of times the term appears in a document over the total number of terms in the document. And the inverse document frequency is calculated by log 10 total number of documents divided by the number of documents with term T in it. And what these parts really mean, and TF-IDF is just calculated by multiplying them together. And the individual parts, what this equation really means is TF represents how frequently the word shows up in the document, and IDF represents how important the word is to the document. So it actually calculates words that are more rare. So what you're trying to do is calculate the importance of a word by saying how often does it show up, but also how rare is the word. And you multiply these together to calculate a numerical data for this the text. And that is all for today. Thank you.